Hello, today we are going to learn about section 1.4, properties of real numbers. So the first property we're going to learn about is the commutative property. So the commutative property of multiplication says you can multiply any two numbers in any order and get the same result. So for example, if I have 7 times 2, that's the same thing as saying 2 times 7. They both equal 14. 5 times negative 12 equals negative 60, and negative 12 times negative 5 equals 60, negative 60. If you notice, I'm flipping the order of the numbers, and I'm getting the same answer. So algebraically, it looks like this. A times B equals C, and B times A equals C. Or we could write it as A times B equals B times A. The commutative property is also true for addition. 4 plus 5 equals 9, and 5 plus 4 equals 9. Again, I'm just switching the order of the numbers. 7 plus negative 10 is negative 3. Negative 10 plus 7 is negative 3. Algebraically, it's written like this. A plus B equals C, and B plus A equals C. Therefore, the commutative property of addition is A plus B equals B plus A. Now let's look at the associative properties of multiplication and division. You can change the grouping of numbers before you add or multiply them and get the same answer. So let's look at addition first. I have 2 plus the quantity 4 plus 5 equals 5 plus the quantity 2 plus 4. Simplifying these, if this property is true, these both sides should equal the same. So I have to start with 4 plus 5 because of order of operations. And so 4 plus 5 equals 9. So I bring down the 2, and I do 2 plus 9 equals 11. Now let's look at the right side. 2 plus 4 equals 6. I'm going to bring down the 5. And we're not sure if these are equal, so I put the question mark there. And then 5 plus 6 equals 11. So yes, it's true. The same thing applies for multiplication. 4 times 5, I have to do this first because it's in parentheses in the order of operation. 4 times 5 is 20. Bring down the 3. 20 times 3 is 60. Now let's see if that equals the same as the right side. So 3 times 5 is 15. Bring down the 4. 4 times 15 equals 60. So yes, that is true as well. So there are two examples of the associative properties of multiplication and division. The identity properties of multiplication and division. When you add by 0 or multiply by 1, the value of the number does not change, whether it's a number or a variable as well. It stays constant. That's why it's called the identity. It identifies the number or the variable. So, adding by 0, we get 4 plus 0 equals 4, 0 plus negative 3 equals negative 3, and A plus 0 equals A. For multiplication, what we do is we multiply by 1. 5 times 1 equals 5, 1 times negative 2 equals negative 2, A times 1 equals A. In all these examples of the identity properties, the answer is always the same as the number it's being added to or multiplied to. So here are 3 more properties that we've talked about, that we need to talk about. The distributive property, we've talked about this one earlier last week, and you've talked about it in previous classes. The distributive property means if we have A times the quantity B plus C, we just distribute the A to both terms. You're multiplying here. You get A plus B, A times B plus A times C. Same goes for subtraction. A times the quantity B minus C, we have to distribute the A to both terms. So we get A times B minus A times C. And here are some examples of the distributive property in work. The multiplication property of 0. It's pretty simple. For every real number n times 0 equals 0. Basically, anything you multiply by 0 will always equal 0. So negative 35 times 0 equals 0. And the multiplication property of negative 1. For every real number n, negative 1 times n will give you the opposite of n. So if you multiply any number or any variable by negative 1, you're going to get the opposite symbol. So in this example, I have negative 5. If I multiply that by negative 1, I'm going to get positive 5. If I have negative 1 times 7, that equals negative 7. Remember, when you multiply two negatives, it becomes a positive. When you multiply a negative and a positive, it becomes a negative. So take a moment and try and identify these properties right here. Here's 4 examples for you. Identify these properties. This first one here is 42 plus 0 equals 42. This is the identity property of addition. The second one here, I have 7 times 2 times 5 equals 7 times 2 times 5. I just changed the grouping of what I want to multiply. This is the associative property of multiplication. This third one, I have 35 times 0 equals 0. Notice anything times 0 is 0, so it's the 0 property of multiplication. Finally, at the bottom, I have x plus y plus z equals x plus z plus y. Notice, all I'm doing is I'm switching the order of adding y and z to z and y. So this is the commutative property of addition. Okay, so let's try and apply these to a word problem. So, suppose you buy a shirt for $14.85, a pair of pants $21.95, and a pair of shoes for $25.15. Find the total amount you spent. So, since we're buying all these items, we're going to have to add them all together. So I get $14.85 plus $21.95 plus $25.15. So this looks like it might be a little hard with the decimals, but knowing mental math, I see that 85 cents and 15 cents makes $1. So I can use the associative property of addition to group these two together. So that's exactly what I'm going to do. I'm going to group $14.85 with $25.15 plus $21.95. Now, 85 cents plus 15 cents gives me a whole dollar. So it's basically like saying $15 plus $25 gives me $40. Then bring down the $21.95. Add them together and I get $61.95. Alright, so another thing we're going to have to do is we're going to have to solve an algebraic expression and simplify it, but sometimes we're going to have to justify each step, meaning give the property that is happening in each step. So, in this example, I have negative 4b plus 9 plus b. If you want to try this on your own, where you write down what is happening in each step, which property, pause it right now and give it a shot. If you're not sure, just follow along. So I noticed that I went from negative 4b plus 9 plus b to negative 4b plus 9 plus 1b. Notice I changed this to 1 times b. That's going to be the multiplication, or the identity property of multiplication. I just represented multiplication with an x because I don't have a lot of room to write over here. Next, I have negative 4b plus 1b plus 9, and I got that from negative 4b plus 9 plus 1b. All I did was switch the 1b and 9, so that's the commutative property since I'm adding here, it's of addition. Then it looks like I have b in both of these terms, so I actually pulled the b out and I have negative 4 plus 1. This is the distributive property, but it's going in the opposite direction, because look, if I distributed the b to both terms, I would eventually get this result. So I'm going in the reverse direction, but it is the distributive property. So I'm going to call it distributive property. Finally, I just add negative 4 plus 1, so that's just addition. Alright, moving on. So the last thing I want to talk about is deductive reasoning. You use deductive reasoning a lot when you're solving mathematical problems and when you're trying to prove things. So, it's the process of reasoning logically from given facts to form a conclusion. In the previous problem, I went from a long algebraic expression and I simplified it. That is a version of deductive reasoning. Sometimes we can prove things are wrong by showing a counterexample. So a counterexample is an example showing that a statement is false. So, in this problem, it says for all real numbers a and b, a minus b is equal to b minus a. Is that statement true or false? If false, provide a counterexample. So think for a second. Listen, and I'll give you an example if it's true or if it's false. So this statement is false because subtraction is not commutative. Subtraction and division are not commutative. You cannot flip them and get the same answer. For example, if I have 8 minus 4, where A equals 8 and B equals 4. Plug these two values in for A and B. Is that the same as 4 minus 8? Well, 8 minus 4 is 4. 4 minus 8 is negative 4. Therefore, that is not true, meaning this statement is false. And that is section 1.4. If you have any questions, feel free to email me. I hope you understood this, and don't forget to take the quiz at the end of this video.